Start recording, and we're going to pull up the. Go ahead and get your books out now. We got to officially start. So y'all gotta look like students now. And let me ask y'all this. Some of y'all that has had probability in high school, how much do you do in hypothesis testing? Do you get into it and then that's it, or do you actually go through and do it?
We touch on it for like a week.
And then that's it?
Pretty much.
I just wondered. Okay, so I'm thinking, I hope this is, yeah.
Is this the stuff that you usually don't get into?
Yes, I get into it, but I usually don't cover it. By this time, this is the last day of class, usually by the time I get to 10.1. Okay, so.
How do we get ahead with all the stuff we do?
Because you don't have to take a test in class, and I don't check for homework. Where's all that done? On your time. See, it's a wild concept. Anyway, hypothesis is a claim. Okay? What is it in the scientific world? It's a swag. What's a swag? Simple, wild guess. Okay? So when you're talking about hypothesis testing, really? You came to school without a notebook?
Yeah.
Okay. Simple, wild, attitude, yes. That's what it is in science. But when you're talking about math, when you're talking about statistics, you're talking about a claim. Okay? A claim is usually substantiated with the word is or was. It all depends on what your definition of is. Who said that? Anybody know? Bill Clinton. I feel your pain. Anyway, it's a claim that usually is substantiated with the word is. Some of y'all don't even know who Bill Clinton is. Is or was. Okay? Is or was. The average is. The average of a study 12 years ago was. So when you see the word is and was, that usually means you're going to be talking about the null hypothesis. We're going to get into the null hypothesis in just a minute. Okay? So I would suggest hypothesis, a statement regarding a characteristic of one or more populations, a claim or a guess, depending on if you're talking about statistics or if you're talking about science. And this right here, what is the claim? That 62% of American adults volunteered their time for charity work. That's the claim. All right? So that's pretty much it. Now, we're going to have plenty of time with the questions we're going to have. I'm going to pull out the null hypothesis. That's step number 1. Get your null hypothesis and your alternative hypothesis. Right now, we're just going to talk about hypothesis. We're not going to get into that. We're going to get into that Tuesday of next week when I actually go into hypothesis testing. Okay? And according to a study, the mean length of a buck was 3.25. So mu is equal to, or in this case, it doesn't say according to the mean length of doesn't say, it's assumed to be a population mean, so it would be mu. Most of the time the question will say, especially when you're doing the testing, it will say population mean, or it'll say sample mean. Now, you're going to be dealing with samples and you're going to be dealing with population. So you're going to have mu and you're going to have x bar. And the formulas we'll have, and that's what we're going to do Tuesday. We're going to actually get into when to use this formula, which is the x bar minus mu, or when to use the other formula, which is the t-scale. Okay? The z-scale and the t-scale, when to use what. And I'm not gonna sit here and do that. I think y'all get it. Wherever you see is and was, that's where you're usually going to find the null hypothesis. Write this down. Steps in hypothesis testing. Make a statement regarding the nature of the population. That's what you're looking for. All right? Collect evidence. Usually there is sample data like 5 test scores, or out of 75 people surveyed, the X bar is 12 and the standard deviation is 3. Okay? They're going to give you a sample. It's called like part 2 of a question. Example, let me go through and write. Where did my whiteboard go? My whiteboard was up. What happened to it? It's a conspiracy. Hold on a second.
Who are we blaming now?
What?
Who are we blaming now?
Well, the Russians or the Nigerians, either one. I thought I pulled up the whiteboard. It was up a while ago. Oh well. There we go. Slide. And let's change it to black. Somebody needs to answer the Twitter. Okay. Let me go back one. There we go. I'm going to give you an example. Let me say something like this. The adult IQ scores have a population mean, or they'll say mu, equal to 100, and a standard deviation of 15. Okay, at this point, you say to yourself, okay, mu is equal to 100, and sigma is equal to 15. Now, why did I write it like that? Because of what word? Population. Remember me telling you that all parameters for population is with Greek what? Greek letters. That's right, class. All right. All parameters, meaning variables that go into the formula, are Greek letters. So when you are presented or when you are presenting, make sure if you're talking about the population that you use Greek letters. Then the question will say, "75 sample," it'll say something about 75 of a sample with a mean of 105 and a standard deviation of 10. Okay? So n, remember us having to take the square root of n? Remember that? Okay? That's where the 75 is. So you would write, and I'm going to put n. I like to put n of s. When we get into chapter 10, I like to say n of s, because that n of s means the sample, the number that's in the sample. If the sample is 75, then that's 75. They'll usually say 75. But what if they give you 10 test scores? Then they want you to find this mean and the standard deviation. And what is n? 10. Okay, so they may either give it to you as just this, or they may give it to you like 10 test scores. Now, if n is above 30, then you use z. If n is below 30, you use t. We'll get to that when we get to the samples, when we get to the examples. So n of s is equal to 75. What is x bar? 105. And what is s? 10. And that is what you have to do when you go through these problems in chapter 10. You have to figure out what they are giving you and what they are what? Not giving you. Now, they don't give you the information to get, and this is one of the things right here. And I'm kind of getting you the cart before the horse, but you'll be okay. Let me give you, highlight this guy right here. Okay? There's 2 or 3 ways that you're going to use the t-scale or the z-scale. One, and I'll write this in red. Red. One, well, if n is greater than 30. And we talked about that with chapter 8 a little bit. If n is greater than 30, then you're going to use the t-scale. And I'll put a t up here. T-scale. Another thing is if the population mean is not given. So I'll put, no, not population, the population mean, put an X to it. In other words, if the population mean is not given, you're going to have to use the sample mean, and you're going to have to plug that into and that's legal. You can do that. But we'll get to that later also. But as you can see, what is the null hypothesis? The null hypothesis, remember, equals here usually means is. So the null hypothesis is the mean is equal to 100. And it'll say something in there like, a professor from blah, blah, blah believes that has changed. So he did a sample of 75 people and found a mean of. So the alternative hypothesis would be, and we'll get into that in just a minute, the alternative hypothesis would be not equal to 100. But we'll get into that. Analyze the data. That means find out what you have and what you don't have. And chances are you need to have these things or a certain number of these things, at least 3 or 4 of these. Okay? And we're going to get to that in chapter 10. Or we are in 10, but later. Any questions so far? The null hypothesis is written as H of O. And you can write that, or you can just write H of O equals, and then put in quotation marks, is, comma, was. Okay? Because that's the words you're looking for most of the time. How do you write the null hypothesis? Well, you write it as H of O. What does null mean? It can mean none, or it can mean initial. I don't know how you spell initial, but anyway, initial. The null vector, or the velocity vector, in physics, okay? Acceleration is at a point of 0, okay? But we're called V naught, okay? Naught, remember the word naught, which means 0, okay? And that's where that comes from, okay? So H of O, colon, or I think that's a colon. Which one is semicolon? 1/2, right?
That's a colon.
Yeah, that's a colon. All right, you can have it as mu is equal to 100. You can have P is equal to. You can have sigma is equal to. You can have any kind of thing. The question will state that. The question will say mu, or population mean, is equal to 100, or is 100. Okay? Most of the time, unless you're in a 3 or 4 level course, most of the time, the null hypothesis will always use what? Equal. Okay? At least for this test, they're going to be equal. Everybody understand that? Because, like I said, the question will say the population is. And what is always been associated with in mathematics? Equals. So I could have H of O, null hypothesis, sigma is equal to 14. I could have H of O, P hat is equal to 0.36. I could have, I'm trying to think, S, or I could have X bar. So you could have S right here. You could have X bar right here, but usually they're not going to do that in this section because it's going to be substantiated with the mean of the population or the standard deviation of the population. And sometimes they'll use P hat or P. So that's the null hypothesis. What is the alternative hypothesis? It's the opposite claim. Now make a note, the alternative hypothesis can be written as H of 1. I've never seen it written as H of 1. I'm going to say H of A. Okay? H of A is what I've always seen. The null hypothesis is always going to be the opposite of the the alternative hypothesis is always going to be the opposite of the null hypothesis. But you have to read the question because there's 2 or 3 ways that you can write the null hypothesis. The alternative hypothesis. Okay, if I give you H of O is equal to, or let me go back. H of O mu is equal to 100. Then, depending on what the question says, I can give you the alternative hypothesis. H of A, mu is what? Not equal to 100. Now, when you're dealing with equals, when you're dealing with the equal sign, with a not equal or equal, which means not equal, you're talking about a two-tailed test. Get your index card out. And right at the top, two-tailed test. Because that index card that we did last week, or whenever we did it, that put at the top, two-tailed test. And then put an equal sign or not equal, put a not equal sign after the sign. In other words, somewhere on the card, you don't have to write it at the top, but somewhere, right on the back when you don't have anything. Okay? Put on the back, two-tailed test, X or not equal. Put that in parentheses, not equal. When you have a not equal sign, that means you're going to use a two-tailed test. And we'll get into the one-tailed test. Well, that means this right here. And you might want to write this somewhere on your card if you got room, maybe on the back. That means you're talking about, I'm going to use a different color, that aqua color. Let's say there and here. And those two sections right here are called your rejection region. And that's why you have to find your z-score or your what? Your t-score. To establish your what? Rejection region. Well, what other kind of tests are they if there's a two-tailed test? Well, let's say that, I'm going to erase this over here. Let's say that you're given a question and they say the mean population is 100. So you say, okay, that's equal to 100. So mean population, H of O, mean is equal to 100. And then they say, blah, 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 believes that the population mean has decreased. Then what does decrease mean? Not equal. It's not going to be not equal. It's going to be what? The H of A is going to be what? It's going to be not equal, but what? Less than. Good. Now you have a one-tailed test. So if you use a less than or equal to or a less than, okay, and we're going to talk about that in a minute because sometimes, now in later classes, you may have a less than right here, then this one will be greater than or equal to. If you had a greater than or equal, or a greater than here, this would be a less than or equal to. Remember, the null hypothesis and the alternative hypothesis always say the what? Opposite. Write that down somewhere. The null hypothesis and alternative hypothesis always says the opposite. So if one is inclusive, what's the other one? Exclusive. If one is exclusive, what's the other one? Inclusive. If one is equal, then what's the other one? not equal. And the alternative hypothesis is always going to be the opposite. Okay? So this is a one-tailed test. Which side? Well, which side is it pointing to? Left, so it's a left-tailed test. And let's say that you find the Z, and the Z is right there, and this is the rejection region. Okay, the rejection region is that area. I'll do it in blue. And we're going to find the Z-score Tuesday. We're going to do that Tuesday. We're going to just bear with me. Okay, what's another one? Well, let's say that the null hypothesis is equal to 100, and blah, blah, blah has done research and found out that he believes, or she believes, that it is increased. So the alternative hypothesis would be what? Greater than, and that is a right tail test. Now, of course, the first question students ask is, how do you know? Well, you got to. What I tell you was the math in probability and statistics is not what gets students. What did I tell you got students at the beginning of the semester? You've got to what? You've got to read the question. Okay? So how do you know when to use inclusive with the inequality? How do you know to use equal with the inequality? The question will say up to, and, or it'll say something like that. So you have to be able to read, guys. You got to read the directions, guys. Because I'm not worried about the girls. The girls are going to read the directions. They always do. Guys don't. That's why we put together things and there's spare parts left over. Okay? So there's your three examples. And remember, depending on the question, and later on you might get a less than. If this was less than, I'm just going to dot this in. If this was less than in a future math class, not in this class, but if that was less than, then this would be what? Greater than or what? Equal to, because this is inclusive, this is what? Exclusive. Exclusive and inclusive, they're always opposite. Now with the equal sign, the only alternative to an equal sign is what? Not equal. Okay? The only alternative to inclusive is exclusive, and the only thing exclusive is inclusive. So if you're using two inequalities, they're always going to be the opposite, and the one's going to be inclusive, one's going to be exclusive, depending on what you're given. Now you may be given the mu is greater than or equal to 5. That's the claim. So if I give you mu is greater than or equal to 5, then the alternative hypothesis is going to be what? Mu is less than 5 because they're opposite. One's inclusive and one's exclusive. See? So it depends on what you read. If you read the directions and you read them well, read the question, read them well, and you should be able to ascertain whether what the null hypothesis is and what the alternative is. But I can tell you right now that in this class, the null is usually going to be equal to. I'm not going to try to get y'all to master all statistics in one semester. Okay? Now, I wanted to put something else here. Let's just use this board. Just ignore this right now. I want you to get another index card out and draw it on your, if you don't have index card, just draw it on your 2 index cards. You're going to have 3 index cards for this test. Now, what should you do after this semester? Throw the index cards away? Yeah, that's the most sensible thing to do, along with your notes. Throw them away too, because you're never going to take another probability class in college, are you? Keep the notebook and keep the cards, because you're going to see this again. I don't care if you're in underwater firefighting. If you get a master's in underwater firefighting or underwater basket weaving, and you get a doctorate, you're going to be in another research class. And you're going to be going over this stuff again. So, what do you do? Well, this one, we're going to call this one left tail. And we're going to call this one right tail. Okay? Left tail, parentheses, and right tail, parentheses. And you're going to put 4 columns. I'm just going to do 3. I'm just going to do 3 examples. I don't even know if you need 4 columns. Okay? And of course, the confidence level. And I'm getting a little bit above myself, but the opposite, the complement of the confidence level that you're going to see in these questions is called the significance level, which is called alpha. We talked about that earlier, but now it's going to be called significance level. So I told you to usually on the index cards, 0.9 to what? 0.99, and I'll do 0.95. Now also the left, what kind of Z or T score are you going to have with the left? A negative T or Z score. So these are going to be negative scores. Remember in the two-tailed test, I told you to use the opposite, the absolute value, because you're going to have one on the left and one on the right. So that's why you use the absolute value, because it's neither negative or positive. I guess you could say it's both. All right? Then what is the significance level? 0.10, 0.05, and 0.0100. Notice, why did I write 4 digits? Because the significant level is a what? Area, so you're going to use inverse what? Norm or inverse T, depending on what they're asking for. Generally, I just use the T to the Z because most of the time the questions are designed for Z scores unless you're doing a section with T values. Now in this case, it's going to be a negative, so that I want you to do inverse norm .1000, because we read from the left, okay, the area on the left, and it should spit out a negative Z-score. So do inverse norm and .1000. What do you get? Should be a negative Z-score. Y'all got a calculator, haven't you? Y'all should be using it right about now. Remember, if you don't have a calculator that's worth anything, go to WADIT-EMU and download one on your Android. I don't know about your iPhone, because iPhone is quirky, so I don't know. Inverse norm, .1000. What do you get?
1.28.
1.28. Okay, now do inverse norm, .0500. What do you get? .64. And somebody do inverse norm of .0100. No yawning in class. What do you get?
2.32.
I'm sorry, what?
Negative 2.32.
So I'm going to highlight the significance level because on the,
Oh, God. I did just do that, didn't I?
highlight the significance level because you want to highlight it. I just hit the wrong button and deleted it, so I'm going to do the right hand now. Okay, I can't go backwards. Just give me a second. Highlight the significance level on that index card, because which way does the calculator calculate the area? Same way we read, from what? Left to right. So on the left tail test, remember the left tail test, let me draw a picture right quick. On the left tail test, what area are you reading? This side right here. So you have to put in 0.1000. Everybody with me? Or whatever. So you need to fill out that index card, and basically these two cards are going to be the same, except one's going to be negative z-scores and one's going to be what? Positive z-scores. So the right is going to be different. The right up here, if I use this right here for my, what is the calculator going to read? The calculator is going to read what side? The left side. So you got to use this area, which is going to be for 0.1000. You got to use the confidence level, which is 0.9000. You see what I'm saying? Because you got to get this z-score that represents 90, not this, because it'd be the opposite, it'd be negative. So doing that, hopefully you understand what I'm talking about. Up at the top, right tail. And the right tail z-score will be what? Positive. So here, I'm going to put confidence level, highlight the confidence level. That's what I tried to do a while ago. Highlight the confidence level on the right tail. On the left tail, you highlight the significance level, because that's what you punch into your norm. Okay? And here, we're going to put significant level, which is going to be the same as the other one. And here, we're going to do inverse norm of the confidence level. So 0.9, and we'll put 4 digits here, 0.9500 and 0.9900. So significance level is going to be 0.1000, 0.0500, and 0.0100. And here we're going to do inverse norm of 0.9000. And when you do 0.9000, what do you get? Should be positive what? Should be the same as the other one. 1.28. And somebody did inverse norm of 0.9500. What do you get?
1.64.
I'm sorry, 1.64? And somebody do inverse norm of 0.9900.
2.32.
Okay, now at this point, some of y'all are saying, well, you're right, you just use positive or negative. Okay, the whole point of me asking you, showing you this, is not for the z-score. That's not the point. The point is so you understand the difference between the confidence level and the what? Significance level. When you see the question in the book say significance level, they're giving you the rejection area. You see what I'm saying? They're giving you that. If they give you the confidence level, then chances are it's going to be on the right-hand side over here. So you need to be able to know the difference between the significance level and the confidence level. On the right tail test, you're going to use the confidence level. On the left tail test, you're going to use the significance level. And that's just so, you're not, suffering from redneck disorder during the presentation or presenting. You actually know what's going on. Okay? All right. I've already talked about this. Two-tailed test is what? Equals. Okay? And they're going to go through and tell you the left and the right. So that's just recapping. I'm just checking the time so y'all don't go into hysterics. See, left tail test and right tail test. Any questions there? So you need to have 3 cards or 2 cards. But you need to know if you make it 2 cards, then you better know your stuff on the second card, because you can get easily confused on some of these questions. Okay? And these are just some examples. We've already talked about it. And there, we talked about these at the beginning of the class. These are just examples. So in this case, the null hypothesis is, and look at the question. It says, a researcher believes that this percentage is different today. Usually when you see the word different, that means not equal. A researcher believes that the mean length call has what? Increased. So automatically, that means greater than. Now, I don't mean to insult your intelligence, but I guarantee you somebody in here is going to read a question and they're going to look at it and they're going to write the wrong thing down. That's why I'm showing you these three right here. And you need to put increased, then you need to put greater than. And remember, if one is inclusive, the other one is what? So which one is inclusive here? The null hypothesis. So therefore, you know that you can't put an equals. Equals can't be in both unless one's not equal. You can't have equals in both. You can't have greater than or equal to an equal. You can't have that. So it has to be greater than. It can't be greater than or equal to. One is inclusive, one is not. Same thing here. If you have an equal sign in the null hypothesis, then you can't have an equal sign in the alternative unless it's not equal. You can, so that one changes to, and look, decrease. When you see the word decrease, that means the left tail test. Less than. These are the two, no, I don't do, there's two right now. There's two answers that I'm looking for. And these are how it's going to be said. Just ignore this. Reject the null hypothesis. Okay, that's one answer. Does anybody know the second answer?
Accept.
No, you can't use the word accept. We'll get into that in just a minute. Because that's one of those things where some statisticians, they go into convulsions if you say accept. All right? So, fail to reject.
Really?
Yeah. Fail to reject the null hypothesis. Now, a lot of people will say, well, Hubert, that basically means you accept. Yes, that basically means that you accept the what? Null hypothesis. I'm going to put that in quotation marks. Accept the whole. All right? That infuriates me when people put a reference to a woman, hoe, and they put O-H-E. Some of y'all are like, well, what's wrong with that? Thank you. O-H-E is a gardening tool, dumbass. Okay? So when you see somebody do that, please put on there, you need to look up your definitions, okay? The slang term is H-O, now you're going to remember. Now you're going to remember null hypothesis, okay? Because it's the hoe, the H-O, the H is the hoe. All right? That's the right way to say hoe, all right? Not H-O-E. Oh! Those are the same people that get me asking questions on Facebook that they can find in Google. What is the definition of blah, blah, blah? Oh, my God. Why do people do that? Anyway, why do we not say accept? Because, let me ask you a question. Let's say that I give you an example of the average green M&M count in a thing of M&Ms is 23. And that's the null hypothesis, right? Everybody with me? Then the alternative is not equal to, right? Well, let's say that I accept the null hypothesis. Accept means that 100% of the time, you're going to have 23 what? Green M&Ms in a bag. What's wrong with that statement?
It's 100%.
It's not that. You are not going to prove the null hypothesis. Okay? You are not proving the null hypothesis. In other words, you can't say 100% of the time you're going to get 23 green M&Ms out of a bag of M&Ms. You're not, that's not your job. So when you say the word except, you're saying that 100% of the time there's going to be what? 23 M&Ms in a bag of, and you know you can't do that. So the word except, kind of associate that with the word prove, okay? Because one of the things about null hypothesis and hypothesis testing is you're not proving the null hypothesis. You're just what? You're just saying whether you reject it or whether you fail to reject. Fail to reject is another way of saying except, but it's not saying, okay, the next time you open a bag of, there's going to be 23, I can bet you a $100 bill on it. No, you don't, because it's not going to happen. Because your job is not to prove it, okay? You're not to prove it. So when you say accept, think of the word prove. Are we going to fail? Are we going to go through all this math and then say, okay, now that we failed to reject the null hypothesis, we're going to prove it? No, there is no thing in statistics that says we're going to prove it. Then if we proved it, then you could say accept. So always remember that. You're not proving the null hypothesis. You're just either you're rejecting it, or you fail to reject. It's kind of like the same. Remember me asking you a long time ago, is OJ innocent? I asked you that a long time ago, remember? I didn't? Y'all were just sitting there like, Did I ask y'all that? Remember when we were talking about compliment? Yeah. Okay, thank you. Appreciate the interaction. Is OJ innocent? Yes or no?
Probably not.
You said probably not. No, he's either guilty, not guilty, or innocent. Which one is he?
Guilty.
He was found not guilty, right? What's the difference between not guilty and innocent? Did I not give y'all the scenario of working at the pizza place? Okay. Well, what's the difference between not guilty and innocent? Innocent, you never go to a court of law. A lot of people say, well, Hubert, that's right. Yes, there are innocent people that are in jail, but the reason they're not they're in jail is because they didn't have that important thing. Starts with an A, and what's it called? Not an attorney. Everybody has an attorney. Alibi. Alibi can be witnesses. It can be what? A TV camera. It can be your imprint on your computer or your cell phone, putting you in Asheville, North Carolina, when somebody says you committed a crime in Anderson. You see what I'm saying? You cannot go to court if you have an alibi. Now, you could go to court with conspiracy to commit murder or conspiracy, meaning that you helped. But as far as doing the actual, why did OJ go to court? He didn't have an alibi. He could not tell people where he was, and he did not have a camera. He did not have a cell phone. He did not have a computer to imprint where he was when Nicole Brown Simpson, his wife was killed. He couldn't present that alibi. And if you can't present an alibi, guess where you're going? You ever seen My Cousin Vinny? Oh my God, I don't even want to ask. I can't believe y'all haven't seen. If you hadn't seen My Cousin Vinny, if you hadn't seen Caddyshack, I doubt very seriously it's not a cartoon. I guess if it was a cartoon, y'all would see it. But anyway, My Cousin Vinny. Has anybody seen it? Okay. Why was the two boys sent to court?
It was something when they went to the gas station at the beginning or something.
Mm-hmm. They went to a gas station. They got some food. They were traveling from New York to California, and they went through Alabama. They thought they'd go through the South, okay? They stopped at a gas station, all right? They got 2 or 3 bags of groceries because that's where they stopped, and of course, it's a convenience store. You pay like 5 times the price, but they wasn't buying chicken and beef, and they were buying potato chips, chewing gum, whatever you buy at a daggum convenience store, all right? They went in the car, boom, they put it in the car, they left, and the next thing you know, the clerk was shot, killed. And they pinned it on these two guys. Now, why did they go to court? Well, they were set back in the 90s, okay? What did convenience stores not have in the 90s or 80s or whatever? They didn't have cameras like they do now, okay? There was no witnesses. There was no witnesses that says these two people did it, okay? So, of course, and there's a part in there where Joe Pesci goes, you're in South Blanken, Alabama. You killed a good old boy. There is no way that this is not going to trial. Why did he say that? Because there was no way, nobody putting them not at the crime scene. You see what I'm saying? So you have innocence, which is somebody, a camera saying this person was in Asheville, North Carolina when this crime took place. Or you have witnesses that say, what does the policeman always ask you when you say you were at some place at this time? What do they always ask you? Can anybody what? Can anybody verify that? That's the first thing they're going to ask you. Yeah, my mom and I was sitting there watching Jeopardy, okay? Or I was at the pizza place and I got in a fight with the waiter, okay? Somebody can put you there. If somebody can put you there, or 3 or 4 people can put you there, you're not going to court. Now, you could be going to court for another reason, like I had my wife killed and somebody, that's another story. But did you do it? No, there's no way you can be in 2 places at what? One time. So there's guilty, not guilty. So think about that when you're talking about accept versus reject to fail. Reject to fail to reject. Okay?
Fail to reject.
Innocent, not guilty. Okay? All right. Question. All right. So I have covered basically 10.1, and I'm just looking over this. I'm not going over the type errors. We're not going over that right now because I don't want to. There's level significance right there. I've already covered that. That talks about we never accept the null hypothesis because it's not our job to what? Prove it. Oh, they used innocent. Did they use innocent? Oh my gosh, I didn't even know that. That's neat. All right. Question. Right, complaint. Okay, next week we will be going into hypothesis testing. So you should be working on 9.1, 9.2, and 10.